In this Korncast, we're going to take a look at imaginary numbers. To start with imaginary numbers, let's simplify the following. Well, let's do this using technology. To investigate this, let's type the square root of -9 into your graphing utility. So when I typed in the square root of -9 into my graphing calculator, I got an error. And it told me a non-real calculation. So what does that mean to have a non-real calculation or a non-real answer? So what we get when we type this in is our non-real answer. So what does it mean to be non-real? So basically a real number is something that we can touch, like 4 or pi. So what we get here is an answer that we can't touch. Let's look at the square root of -9 in more detail. I know I can factor -9. So I'm going to get the square root of -1 times 9. Now using the product property of radicals, I know that I can rewrite that as the square root of 9 times the square root of -1. I know what the square root of 9 is. It's 3. So what I end up getting if I simplify this is 3 times the square root of -1. So what we conclude is that the non-real answer comes from this part of our expression. Not the 9, but the square root of -1. So the square root of a negative number gives us a non-real answer. A famous mathematician by the name of Euler was very interested in this. Euler had a profound impact on mathematics and physics. And one of the impacts that he had on mathematics was that he was the person who defined the square root of -1 as a variable. In this case, I. And that's one of the nice things about mathematics is that if we have something that is causing us a problem, for example, the square root of a negative number, that we can let it be a variable. Now we call I an imaginary number. So the definition of the imaginary number is any number in the form of k times I, where I is equal to the square root of -1, and k is any real number. Please take a moment and write this definition down. Now one of the nice outcomes of this definition is that if I have my equation I equals the square root of -1 and I square both sides of my equation, I'm going to be left with I squared is equal to square root of -1 squared is really going to be the square root of -1 times the square root of -1. So we're going to get I squared is equal to, well, the square root of -1 times the square root of -1 is -1. Because we know that if we multiply the square roots of the same number, we're going to get that number as a result. So this is a nice application of imaginary numbers. So now let's take a look at some examples of working with imaginary numbers. Well, from our previous observations, the square root of -9 can be rewritten as the square root of 9 times -1, and the product property gives us the square root of 9 times the square root of -1. And again, the square root of 9 is 3. And now we can take a look at the square root of -1. Well, by definition of our imaginary numbers, the square root of -1 is going to give us I. So our answer is going to be 3 times I. So now we have the ability to simplify square roots with negative signs inside them. And that's kind of nice. In example B, I know -16 can be factored into -1 times 16. So I'm going to get the square root of 16 times -1. Again, with our product property, we're going to get the square root of 16 times the square root of -1. And lastly, I know the square root of 16 is 4. And I know the square root of -1 is, you guessed it, I. So the square root of negative 16 is 4i. Now again, continuing on with the simplification of our radicals. I know that this answer is going to be a non-real answer because I'm taking the square root of a negative number. I know that the square root of negative 8 could be rewritten as the square root of 8 times the square root of negative 1. Now to simplify the square root of 8. Now the square root of 8 can be rewritten as the square root of 4 times the square root of 2. And then we're going to multiply our square root of negative 1 to that. Well, the square root of 4 is 2. The square root of 2 is the square root of 2. And lastly, the square root of negative 1 is I. So I'm going to multiply that to I. Now I must make sure that my radical ends and then I multiply I to that. I don't want to have my I inside the radical because that means something completely different. So there's our answer. The square root of negative 8 simplifies to 2 root 2 times I. I can rewrite the square root of negative 48 as the square root of positive 48 times the square root of negative 1. I know that the square root of 48 is really the square root of 16 times the square root of 3. And then don't forget to multiply that by the square root of negative 1. And lastly, the square root of 16 is 4 times the square root of 3, which is the square root of 3, times the square root of negative 1, which is I. And again, there's my answer for the square root of negative 48. And finally, let's take a look at some examples involving just i's. Now, simplifying the following, we notice that we have I to the fourth here. So we have to use the fact that I squared is equal to negative 1. So I'm going to factor this into I squares. So I'm going to get I squared times I squared, because I know using my exponent property that I add my exponents. And now, because the definition of my imaginary numbers, I know I squared is equal to negative 1. My I squared is equal to negative 1. And now, finally, I can just multiply. So negative 1 times negative 1 is 1. So, I to the fourth simplifies to 1. And I think this result is pretty interesting. And now, let's look at our final example. The quantity 2i cubed. Using my power property of exponents, I know that I can rewrite this as 2 cubed times I cubed. 2 cubed is 8 times I cubed. You're probably thinking to yourself, I'm done. Well, you're not done. We can simplify I cubed a little bit. So again, I'm going to factor I cubed with an I squared, because I know what I squared is. So I'm going to get 8 times, well, factoring I cubed, I'm going to get I squared times I. Now the last thing I'm going to do is I know what I squared is. I squared is really negative 1. So I'm going to get 8 times negative 1 times I. So the last thing I'm going to do, and this will be my final answer, is negative 1 times 8, which is negative 8 times I. So my final answer for the quantity 2i cubed is going to be negative 8i. And that concludes the imaginary numbers. Imagine the possibilities.